A bullet of mass m and velocity v initial is fired toward a block of mass 4m as shown in the figure below, this figure right here. The block is initially at rest on a frictionless horizontal surface. The bullet penetrates the block and emerges with the velocity of the initial velocity divided by 3. Determine the final speed of the block, the loss in kinetic energy of the bullet, the gain in kinetic energy of the block, and the total change in kinetic energy of the system. So these are the equations that we're going to use. So the momentum is equal to the mass times velocity, and the kinetic energy is equal to 1/2 the mass times the velocity squared. So now first we need to find the speed of the block. We can do this using momentum conservation. This basically states that the momentum before a collision is equal to the momentum of the system after the collision. And that's always true. So the mass of the bullet times its initial velocity is equal to the momentum of the bullet after it goes through the block, since it still has a velocity. So the mass times the velocity of the bullet after it goes through the block, which is the initial velocity divided by 3. And then we need to add that plus 4m, that's the mass of the block, times the velocity of the block. And it's asking us to find the velocity of the block here. So first off, we can just cancel everything. And now we just need to solve for the velocity of the block. And then if you solve it, you should get that the velocity of the block is equal to the initial velocity of the bullet divided by 6. And this answers part A. Roll A there. I'm going to write this up here instead. The final velocity of the block is equal to the initial velocity of the bullet divided by 6. Okay. Now next we need to determine the loss of kinetic energy of the bullet. So I'm going to erase this right here. And now the loss of kinetic energy is simply the change in kinetic energy of the bullet. So that is basically 1/2 the mass times the initial velocity times the final velocity of the bullet squared minus 1/2 mass times the initial velocity of the bullet squared. And now we can just plug all of our values in. So we get 1/2 m. Now the velocity of the bullet after it goes through is the initial velocity divided by 3. And subtract that by this one, which is the kinetic energy of the bullet before it goes through the block. Now if you just simplify this, you should get that it is equal to minus 4/9 mv squared. And so the kinetic energy, the loss of kinetic energy of the bullet is equal to minus 4/9 times its mass times the initial velocity squared. So I'm going to write that up here. Change in kinetic energy of the bullet is equal to minus 4/9 mass times the initial velocity of the bullet squared. And that's part B. I'm gonna erase this part here. Now we need to find the gain in kinetic energy of the block. Now this is fairly simple. since this is just simply the change in kinetic energy of the block. So again, changing kinetic energy is the final kinetic energy minus the initial kinetic energy. Now the block says it's initially at rest, so in this case the velocity will be 0. And since everything multiplies together, this whole part of the equation simplifies to 0. So we can just omit this. So it's really just 1/2 times the mass times the final velocity of the block after it gets hit by the bullet. So you can calculate this by simply substituting its final velocity, which is this one. Then we're just going to substitute this right here. And then you can just simplify this to get 1/18 times the initial mass of the bullet times the initial velocity of the bullet squared. So I'm going to write this up here. The change in kinetic energy of the block is equal to 1/18 mass of the bullet times the initial velocity of the bullet squared. And that is the answer to part C of this problem. Now we still have one more part which asks about the total change of kinetic energy of the system, both the bullet and the block. So this is simply the kinetic and the change in kinetic energies of both just added together. This is the total change in kinetic energy of the system. And now we just substitute our values in. So we get minus 4/9 mv squared plus 1/18 times the mass times the initial velocity squared. And then if you just simplify this, you should get that equals to minus 7/18 times the mass times the initial velocity squared. So the total change in kinetic energy of the system is equal to minus 7/18 times the initial mass of the bullet times the initial velocity of the bullet squared. And that is the solution to part D of this problem. Kinetic energy. Now you might notice that we have lost a little bit of energy, and this is because the collision is inelastic, so some of this energy gets dissipated as heat into the surrounding area. So this is part A, this is part B, this is part C, and this is part D. And that is how you would solve this problem.